Alright, so you have created a digital elevation model and a canopy height model, and this is how they come in. These are LiDAR derived, 1 meter resolution, and the first thing we want to do is generate the hillshade model. So search for tools, search is here, so click that, the search bar will appear, search hillshade, enter. Hillshade 3D or spatial analyst, same thing, whichever software you have. And think. It's going to think about it for a minute because I clicked on it twice. Don't do that. Oh, come on now. You can do it. If you click on it a third time, it might blow up, or crash, or do any other number of super awesome fun things. And once I get this uploaded, I'll clip out this section of audio. So if you're listening to this, it's brand new. Come on. There we go. And there it is on the other screen. So there's our input raster and output raster here. So our input raster is going to be our digital elevation model, and our output raster is going to be a .tiff file. And this is being very nice and slow for me today. Go here, click here, and save it in some folder that you like. And I'm not going to hit OK because we'd be here for the next 10 or 15 minutes. Because this is a very big model. But that will generate a standard hillshade. The other way to do things is to go under Windows Image Analysis, and then let's go ahead and select our digital elevation model, whatever DEM you have, and then this f of x add function, and click once identity function so it's highlighted, then right click and insert function. And you may have the multidirectional hillshade function, which is something that you can add in if you don't have it. I'm not sure if the newer versions of Arc have this built in or not, but if not, you can search for multidirectional hillshade function, ArcGIS. When you've downloaded that and installed it, this will appear, and then you can use that, and this I will run because it's very quick. And there is our hillshade model. Lovely. So then we can take our let's see, where did that plop that? That function DEM fill.tiff, that's our hillshade, and we have our DEM raw here. If I place that on top, it gets hidden. And then I can go ahead and go to stretched, color ramp, use this elevation gradient, apply, good color. And I also have the option to take the statistics from the current display extent or from the entire raster dataset. So if I use the entire raster dataset, you see that's looking at the entire dataset and giving the high-low values as different colors. If I use the current display, that's showing the highest and lowest values within the scene itself, which is what I prefer for this. So last step, we have to go to display, transparency, I like 60%, so there we go, there's that. And now we have elevation tinted hillshade, so that's a very nice thing to work with. If I zoom out, you'll see this color ramp changes, and that's because I have it displaying from whatever high-low values it has within this scene. Now, the canopy height model, so I'm going to uncheck that and that, and I'm going to go down to my CHM here, and that I've cleaned up to take anything that appears to be an issue with data quality, which massively high or low values, which aren't realistic. And if we zoom in, we can see here's the individual trees here. This is a 1 meter resolution model. You can see that tree has a canopy 1, 2, 3, 4, 5, 6, 7 cells, or 7 meters across. Nice large tree. We can use our information tool here to click upon that and find out that that opened up on the other screen, but that is a pixel value of about 21 meters, and you can convert that to feet, 60, 70 something feet. We can also get fancy and say, instead of a stretched, I want to see anything that is symbology classified. And let's just give me 2 values here, and I'm going to classify that and say, show me anything that is over, let's just say over 20 meters in height. So that's relatively few, so you see most of these cells are less than 20 meters and a few of them are above. So that's going to show us the very tall trees. And let's see, that's where the very tall trees are. That could be useful for a number of things. Let's go ahead and change that a little bit more. Let's give that 3 categories, and we'll say one of those is going to be 20, and the other is going to be 15, and that's going to show us a little bit more in terms of detail. And there's some of our bigger trees. You can see some history in there, probably a super canopy white pine there, and there. Nice run along that stream there. There's a stand of older trees there. That looks interesting, so I'll go on over here. But the way that I like to display a CHM the most is under stretched. Use the color ramp that goes, let's see, is this the one or is it this one? One of these. Let's try this one. I think that ends up giving you sort of the bubblegum pink for the highest categories. And just like with the elevation model, I like to use the current display extent to show the highest and lowest trees in each view. You can also use the entire view to show you more of an objective sense of, well, you might have the tallest tree be 20 meters here and 30 meters over there. If you want to see a 20-meter tree is the same color all the time, you would use that. And let's apply and see that. So a tree of that height is always going to be that color. But if I go and say from the current display extent, that's going to change slightly, not a huge amount until I zoom in here. But now that's going to change. Now I can see those are the highest values within this view. You can see some canopy gaps here, bigger trees here. That's interesting. Zooming out, you get more of a view. This is just an area where a lot of larger trees are. Let's zoom in here, and you can see how that changes. I like to view it that way because it shows me more detail on whatever I'm looking at relative to what's within the scene. But it can also make sense to change that and say from each raster data set. And that way, see, that's a fairly tall tree, and I can use the identify tool to find out just how tall. That looks at that one cell, 22 meters in height, convert that to feet. And that is always going to be that color, and that's always this color. So there's, looks like a brighter shade of pink here. That one's 26 meters. Very nice. And then if we zoom out farther, let's see, what else can we see? Nothing too shocking there. You can see down to the level of where there's a cutoff on that road. A lot of neat stuff. You will find some issues with the data set where the laser bounces off something it shouldn't have done and gives you an incorrect value. So watch out for that. But the broad trends here, that looks like a boundary between management. And that is, looks like a beaver flowage there with a dam there. All sorts of neat stuff that you can find in these data sets. But those are the basics of navigation. So you have your canopy height model, and then you have your elevation model with hillshade. And that's the same beaver dam and flowage there. So those are the basics, and of course I'm here for questions as they come up.